A warm welcome from my side as well. So some people found the way. Let's try to cover the hard hours after lunch with something interesting. What I wanted to show you in the next half an hour or 25 minutes is something we support, develop, and deploy at Cyan. I'm not sure who is familiar with the company name, Cyan Incorporated, based in Petaluma. We have two tracks in our product line. One part is the hardware side, so we support the full 100G services, packet optical, means on the DWDM side up to the packet transfer Metro Ethernet, MEF 2.0 certified. I will not talk too much about the hardware in detail. Just be aware of that we do optical transponding, MUX-ponding, as well as packet transponding, MUX-ponding. So you have the full 100G services available on our platform. The key is more that Cyan has a very strong grip in the range of software support, of managing networks, of our customer deployed networks. Not only from the operational perspective, but also from the topic of orchestration. So the key strength of Cyan is really third-party integration, where we talk about managing networks being combined of our equipment, of Juniper, of Cisco, and other third-party devices like RUT, Exedion, Overture, and so on. The key thing here is to show you how this whole story developed and what's really behind orchestrating VNFs. And let's start quickly with an overview. I think you're all familiar with this. So if you look at the developments between application and network infrastructure of the last nearly 20 years, you really see that we really went from the application based on host systems into systems where you had an infrastructure. Protocols were the key, and topologies like token ring, FTDI, all that stuff. But more and more, the application really defines in the end how the network infrastructure has to look like, and that's the key that the key sentences here. So network defined by the needs of applications. That is what we are in today. And that's where operators have to become ready for, with the cloud services and software as services and so on. And the applications are not constrained by limitations of networks anymore. That changed completely. So for us and for many operators or key infrastructure vendors, the driving power in the market are customers like Amazon, like Google, like Facebook. They define how the networks look like. It's no longer that an AT&T and however TPSA defines everything. Yeah? The key requirements come from the application side. So that's why network transformation is on the way. And as I mentioned already, Cyan provides two parts for this transformation. One part is the hardware infrastructure, purpose-built packet optical transport platforms that can be combined together with other third-party vendors. It's nothing that is proprietary here. But the key is really Blue Planet. So this was and I say it was the first SDN NFV orchestration platform, because as you can see, we deployed this SDN controller software in 150 customer deployments worldwide. So it's not a question of being production ready, it is in production. And that's the key difference to everything you hear or maybe have heard since the last year summer, because everybody says today, oh, we do SDN and something like this. But it's really that we not only develop something for our own equipment, it's really in production in combination with third-party vendors of other companies. And the key thing what happens here is that the automation takes place in these networks. It's about discovering the network for the operational part, simplification, so setting up services like EVPLs, EVLANs, and so on, all these Metro Ethernet services, they are done really graphical by point and click from A to Z, and the SDN controller calculates the complete route through the network, and then pushes this information, this configuration information, to the network infrastructure. That's the key difference. So a good word here from one of our customers in Europe, a quite big operator. They said before we used Cyan, we normally required up to 40 days to bring up a layer 2 service for a customer, from customer order in to provision service, because you need to touch this and this and this equipment by this specialist and so on. And this really changed because today they have provisioning times of 1 or 2 hours. If they have to install something, maybe 2 to 3 days. But from this moment on, the operator makes money because he can charge for the service. And that's how they really start to make money, with creating services with our platforms. And besides, the infrastructure is far more cheaper because the intelligence is in the software and not in the hardware in specific ASICs, because today you pay a lot of money for specific routing, switching hardware and so on with intelligence. And that's centralized in the controller platform. Then it's all about automation. That comes with the simplification. So what we also provide are open APIs. So our partners, customers, they develop own applications just to provision their services using the API. For example, we were the first one, I think we are still the only one, providing a MEF2 API for all our equipment. So you can just define your own provisioning procedures, whatever, to manage the to provision services automatically. And the next step is all about virtualization. And here then we come into the range of cloud operations and of data center operations, where we just see the trend. It's not a trend, it's already there, that the customers go away from installing appliances for every single kind of service, like an appliance for firewalling, an appliance for encryption, an appliance for load balancing, for DPI, and so on. They just move these equipment into virtualized containers and virtual network functions on their server platforms. And that has to be supported in the orchestrations, and that's what we do. And what's more behind here, this is what we have with Blue Planet. It's really a whole new world. It's purpose-built, the whole story. And just to give you a brief step into SDN, just for one slide. So just to repeat it, the SDN controller software, that's the key. And that provides the standardized communication to the network hardware here, to the infrastructure layer, and open APIs to the application layer. That we offer services, applications for this. It's like a smartphone. You have an iOS or an Android, and you just purchase the apps you want to use. And just to decouple the software control from the hardware completely. That's the key thing. So to compare it a bit, the first step was made by Juniper in the 90s, end of the 90s, by taking the routing engine away from the switching. Routing engine separated from the switching, from the path. And that's the next step, to take the topology management out on a software-based controller platform. So Blue Planet provides the multi-vendor network orchestration, and that's the SDN part. And this SDN part is important to get a flexible infrastructure, because if you have a service that needs bandwidth in a specific case, or connectivity from a data center to another data center, or from a customer side to a data center, whatever, then you need to have the network being configured automatically. And here I talk about seconds, not about days or hours. That has to be done very quick. That's where you need the Blue Planet as a key. So your wide area network, the metro network, becomes flexible for service automation, for end-to-end service provisioning automatically, and really get a high service agility so that the services are set up very quick. The next step, and that's the key thing, is the orchestration of all this stuff. So if we talk about orchestration, we talk about the possibility not only to manage your infrastructure, but also manage resources in the cloud to provide software as a service, infrastructure as a service, and so on, based on OpenStack. So it's absolutely open. It's not, because some customers even tell us, like a Deutsche Telekom, they even tell us OpenStack is a must, VMware is proprietary. For them, it's even proprietary. So anyway, that just is as a side note. And on the other side, the VNFs, the virtual network functions in the data center part, for example. And such a virtual network function can be a virtual evolved packet core, a complete one, a virtual firewall, a virtual encryption, and so on. So the architecture, by definition, is that you have the operating system, you have the multi-domain orchestrator, and multi-domain means it's able to manage the network part as well as the data center and the cloud part. That's the key infrastructure that's defined by the SDN NFV architecture. And what we do with Blue Planet, with the orchestrator, is the multi-domain service orchestration by Planet Operate for the network, and the orchestration of cloud management and resource management for the data center on the other side. So this means you can really get everything in one hand to enable a service from A to Z. Because the time is quite short, I think the key question is everything clear? And I guess maybe not. So I think it's better to have a look at a practical example. This example can also be viewed via Vimeo from everybody. So that's just an open thing. And let me try to get now the, I guessed it. Let me show you now just a video that's from an Etsy POC. This is about orchestrating virtual firewalling and virtual encryption with SerDes and Fortinet in this case, and RUT equipment, and also Cyan equipment. And just listen to the speaker. So he will explain everything, how this looks like.
Director for NFV and SDN at Cyan. On June 17th, Cyan introduced Planet Orchestrate, a state-of-the-art application for Blue Planet that orchestrates virtual resources with the WAN to create new and value-added services.
Minutes, I will demonstrate what we believe is an important first use case for NFV technology through our new Planet Orchestrate application for Blue Planet. This Etsy-approved and CenturyLink-sponsored, multi-vendor, distributed NFV real-life use case is brought to you by Cyan, RAD, Fortinet, and SerDes networks. The concept of distributed NFV is to use an orchestrator to run and operationalize virtualized network functions where it makes sense the most. A centralized data center, a POP, a central office, or a virtualized customer premise can be any of the locations that Cyan's NFV orchestrator can provision services. In this particular case, Planet Orchestrate will set up a virtual firewall from Fortinet and a virtual encryption engine from SerDes networks on RAD's NFV-capable NIDs. An alternative approach that Planet Orchestrate supports is to use a simple NID attached to separate servers and provide the same virtualized CPE functionality. Planet Orchestrate is agnostic to the location of the servers and can operationalize virtual network functions anywhere and anytime. Now we will log into Planet Orchestrate's web-based interface. All the functionality provided by this interface relies on APIs that can be directly used to automate service creation. Fusions represent deployed and available virtual and physical resources. From the service tray above, or also known as a product catalog tray, we can drag and drop an icon to create the element management systems for the firewall and encryption virtual network functions. From the drop-down menu, which can be customized through simple service template changes, we can select various options that help configure instantiating the virtualized DMS. We can set where the virtualized DMS should be installed, the internal and external networks that the DMS should use, the domain it should belong to, and other options that we can add to the menu. Once the virtualized DMS is created, it will show up as a virtual resource as part of this domain. By clicking on this resource, we can open up the virtual EMS for the firewall and encryption engine on separate tabs of the browser. In this geographical view of the two customer premises, an enterprise customer can use a self-serve portal, or a service provider can provision infrastructure network circuits using the services of Planet Orchestrate by simply drawing a line between customer premise locations modeled as Layer 2 networks. Planet Orchestrate will either call Planet Operate, Cyan's WAN management solution, or a third-party tool to discover the end-to-end network topology. Then various endpoints can be selected as the E to Z EVPL endpoints to establish a metro circuit. The EVPL circuit can be cross-checked on the Planet Operate graphical user interface.
And just a brief interruption. So this is really the key what I talked about regarding SDN capability. So you see the layer 2 circuit between the RUT end devices, the NITs, throughout the network is established. That's just a logical topology over all the layers. It's just done automatically. It's created automatically in seconds. No hands-on provisioning. It's just done on the fly to provide the service with the required bandwidth.
Virtualized CPE applications are the last step in creating an end-to-end service between enterprise locations by the drag and drop of the CPE icon into the CPE L2 networks. The private network interconnects the distributed VNF appliances and their respective EMS applications. The public network provides login access to VNF appliances from outside. The service chaining of DNF applications is made possible by the checkbox selection of three permutations: firewall plus encryption, firewall only, or encryption only. Unselected VNF applications will have a grayed out tab in this graphical user interface. VNF instantiation is repeated on the branch office. Traffic flow between UNI and NNI ports of the NID runs through the firewall and encryption virtual machines. Virtual network interconnection points on the VNF instances are set up by Planet Orchestrate. The encryption EMS discovers its VNF clients and helps with editing, enabling, disabling encryption policies from one location. End-to-end video streaming between CPE servers flows through the transport network encrypted. Wireshark tapped into the NNI port of the source CPE NID device displays the Ethernet frame type as 891E as the fully encrypted layer 2 frame. Similarly, the firewall EMS can centrally control the end-to-end data path as it flows through the firewall policies set up in the firewall VNF appliances. Deletion of the VNF instances at the CPE locations, one by one, is as easy as their creation from the same Planet Orchestrate graphical user interface. The dynamic transport circuit created for the distributed NFV or virtualized CPE can also be deleted from Planet Orchestrate.
So these were just the NITs from RAD that have the capability of running the virtual network functions. So just a normal server for the cloud management.
For more information on Cyan's Blue Planet SDN platform or the company's participation in other trials and proof of concepts, please visit us at cyaninc.com.
So don't forget, a wizard never comes too late. So this is something maybe a bit overwhelming, maybe not, but you see where the direction goes through. So that is what's available today. And this is what will be deployed in the future. So there are big installation fields tests with large providers in the world running exactly these services, these services especially also for virtualized CPE services and so on, to get rid of hardware installations and all this big bunch of different vendor equipment they have normally installed in the network. Yeah, I hope it was a bit interesting, useful for you to give some idea what's doable today, what's state of the art. It's not only state of the art or bleeding edge, it's just leading edge technology, and the key is, as you saw, third-party integration. That's the key thing to manage a network under one control, orchestrated in a right fashion, in a new manner. Yeah, that's from my side. So I think we come to the question parts, if there are questions. If not, then I say thank you from my side.